For the last of our graph demonstrations, we're going to take a look at Dijkstra's algorithm, and we're going to apply Dijkstra's algorithm to a directed weighted graph. First step, we're going to start out at A, and we're going to figure out where we can get to from A that's better than what we've already got. Now again, all of these are infinite to start out with, so anything is going to be an improvement over that. So we take a look at all of the edges originating at A. We have an edge from A to B at cost 20. Well, 20 is better than infinity, so we have a new lowest cost path from A to B, and that's cost 20, and that's from vertex A. We have another one from A to G, that's cost 90, and that's also from A. And we have another one from A to D, and that's 80, and that also originates at vertex A. And all of the remainder are going to be infinity, because we have no paths to any of those vertices yet. In the next step, we're going to take a look at the lowest cost path of all of the ones we have so far. We have 80, 90, a lot of infinities, but we have a 20. So 20 is the best we've done so far. So we're going to pick that as our lowest cost path, and we're going to say that that one is now complete. So in our next round, we're going to start out the search at the place where that lowest cost path has taken us, which is B. Now B, we already know the lowest cost path is 20. But we're going to see where else we can get to from B that we haven't been to before. Well, B only has one edge originating, and that takes us to vertex F. Now we haven't been to F before, so its cost is currently infinity. So the cost to get to F via B is just 10 more than whatever the cost it was to get to B. So in other words, 20 plus 10 is 30. And that's a path via B. Everything else is unchanged, so we're just going to copy it down. In the next round, we're going to take a look at all of the paths we have so far, excluding the one that we've already picked. And we're going to find the lowest cost path. Well, in this case, it's the newest one that we've added, which is 30 to F. So F is going to be our starting point for the next round. Now we have two edges originating from F, one which takes us from F to C at a cost of 10. Now that's 10 plus the cost we have already of getting to F, 30. So 30 plus 10 is 40. To get to C, 40 is better than infinity. So we have a path to C, cost of 40, and it comes from F. We also have an edge from F to D. Now the cost of that edge is 40. Now 40 plus the cost of A to B to F is a total of 30 plus 40 is 70. Now our path currently to D is cost 80. 70 is an improvement, so we'll take 70 instead. And that's via F. And nothing else changes. So 20 from A, still no way to get to E, 30 from B, 90 from A, and still no path to H either. In the next round, we're going to pick the lowest cost path of all of the ones that we haven't completed yet, and that's this one over here. So our path to vertex C at cost of 40. So C is going to be our starting point for the next round. Now there's several edges originating at C. One takes us back to F at cost 50. Now that would give us a total cost of, well, 40 to C plus 50 more is a total of 90. Now 90 is not better than 30, which is of course what we'd expect because we've already found the lowest cost F. But we do have one from C to H, and that's in addition to the cost of getting to C in the first place, which was 40. So 40 plus 20 is 60. 60 is a big improvement over infinity, so we'll take that one. Path to H, cost of 60 coming from C. We also have an edge from C to D at a cost of 10. Now 10 plus the cost to get to C of 40 is a total of 50, which gives us a path from A to B to F to C to D of cost 50, which is less than the cost of the path we have so far. So we have another improvement. 50 to get to D via C instead. And that's the only change. So everything else gets copied down. And that's still the best path to B, and that's still the best path to C, and that's still the best path to F. But of what we've got left, this path to D is now the lowest cost path. So we finally settled on a path to D that's going to be the best that we can get. So that's at a cost of 50. So now let's take a look at where we can get to from vertex D. From vertex D, we can get to vertex G at a cost of, well, 50 to get to D in the first place, plus 20 from D to G, grand total of 70. 70 to get to G, well, that's an improvement over the direct route from A to G, which was 90. So 70 is better than 90, so we pick 70 instead, and that's via D. But that's the only new path we have. That's the only edge we have originating at D, so everything else just gets copied down once again. And we're already done with this one, and this one, and this one, this one. So now our next lowest cost path is this one to H at a cost of 60. So we're going to pick that for the next round, and we're going to start exploring paths starting from vertex H. Now vertex H is very interesting because there is no edges originating there, so there's nothing more we can do. All we're going to do is say that everything stays the same as it was before by copying everything down. And all the finished paths are still finished. And of the remaining unfinished paths, the lowest cost one is this one over here at cost 70. So we're going to mark that one as finished, and we're going to add that vertex G, and we're going to take a look at all the edges starting from G. Now there's only one edge originating at G. That takes us back to A at a cost of 20, grand total of 90 to do a round trip back to A, but we weren't trying to do a round trip in the first place, so that adds no new information. Everything just gets copied down. All of these are complete, which leaves us with one last value, which is E has a value of infinity. Now in this case, the value of infinity tells us that there's no path to E at all. And in fact, if we take a look at the vertex E, we can see, of course, that there are no edges leading into E, which means that there's not going to be any way of getting there. And having the value infinity left over as our result shows us that there is, in fact, no path to E. So we can mark it is done. That's the best path we can get, none at all. And now our Dijkstra's algorithm, finding the lowest cost paths from A to all the other vertices in our graph, is complete.